Quantitative skills are ability to create numerical manipulations and results. So that is using and applying math and statistics, and you guys are very good at that. Qualitative skills, ability to think and write about your work beyond numbers and to describe the relevance of your results. And as you will see later on, when you write about your output, okay, I would like to see 3 things, okay, as I will discuss later on. Okay, 3 things. But before that, okay, let's just differentiate primary versus secondary sources, and this will be useful not just for this course, but of course, in your researches as well. So when we talk about primary sources, these are data that come directly from the entity collecting the data and or analyzing it to find a result. So these are definitive sources of information, and of course, we prefer primary sources. Sige, guys, can you give me an example of primary sources? We mentioned secondary source. So here we see here it cites or reuses the information from the primary source. Okay, it may use the information in different ways. Okay, so this is one of the dangers. Now it may use the information in different ways, inconsistent with the primary source's stated goals. So you have to be careful. You have to watch out, of course, that you don't commit this error. Kasi and when you later on review materials, okay, literature, you have to watch out that when you encounter secondary sources, that the data are actually presented in alignment with the original intention, okay, original goal, why that data was obtained. Kasi in some cases, they can be manipulated, di ba? So you always have to take this into consideration. And they may incorporate biases. So pwedeng portion lang nung dataset yung kinuha so that it can support the conclusions, for example, of the author. So you have to make sure that you review the context as well as the method by which the secondary data was obtained and was analyzed when you encounter them. Okay? Other notes on sources. So you have to know, okay, you have to know the year, the trend in the change of the data, the geographical context, okay, and the scope of the estimate. Bakit kaya importante itong mga to? Reference your sources completely to facilitate replication and verification of your work, okay? So in your future projects, please do this, no? Please observe this one, okay? And in the case of multiple sources, so say you're doing a literature review and you were able to, on say life cycle analysis of coal power plants, and you were able to find several sources, okay, you have to cite at least 3 if available, okay? You have to summarize the reasons for differences. So maybe some of the reasons for differences are these things, no? Year, trend in change, geographical context, scope of estimate, or maybe the way they analyze the data, okay? So the way they model the life cycle analysis. So as I mentioned in the discussion of the syllabus, there are 3 main methods. Baka magkakaiba sila ng ginamit. Okay, so you have to cite these differences. And then exercise judgment on how quantities will be used in analysis or why the values are not relevant to your study. All right? So hindi lang basta-bastang, okay, study 1, 2, 3 also did this, period. And then no other thing. So you have to give reasons for bullets 2 and 3. Okay? Okay, so and it is good practice to summarize sources in a table. Basically, it's better when you can provide a table, okay, summarizing your different sources, and then the important things from your sources, so that it's better for you, it's easier for the reader to understand what the differences among these different sources are. Okay, and then for you also, in the process of writing your paper, it's easier to organize your thoughts later on. Okay, so this is just an example, okay, of how you might present, how you might present your information. So for example here, okay, in the first column, you have the value, okay, in terms of CO2 emissions, okay, in million metric tons, okay, and then you have the source, okay, and then you have the type of source. So is it primary or secondary? And then comments on this particular source. All right. Okay, next, accuracy versus precision. You are familiar with these two, but let's just review them. When we say accuracy, it's how close the expected value of your sample is to the population value, while precision is how low the variation in your sample values are. So the usual representation of those two ideas is dartboard. So this one, the top left, is a representation of accuracy. Okay? Ay yung nasa right, top right, more on precision, di ba? Hindi siya masyadong accurate pero mukhang precise siya, etc. Okay, and then itong nasa lower, hindi sila accurate and hindi sila precise. Okay, and then you have the idea of variability and uncertainty. So when we talk about variability, this is due to the heterogeneity or diversity of a system. So inherent siya doon sa system. Uncertainty naman is due to the imprecise measurement of a value or the lack of full information, or you are ignorant of the state of a particular system or a particular product. So those are sources of uncertainty. Okay? So naintindihan natin yung difference ng variability and uncertainty. Yeah? Okay. And then in presenting your data, okay, you can make use of ranges. Okay? So you can have limits, you can have minimum and maximum, and then you can have percentile limits. So for example, 55th percentile and 95th percentile. And then you can do bounding analysis. So bounding analysis is useful when you do not actually have data, but have a firm belief that a value is unlikely to be beyond a certain quantity. And this belief could be qualitative, no? So a bounding analysis of energy technology might lead you to conclude that given other technologies, it is unlikely that an efficiency value could be less than 20% or greater than 90%. Now, using a range in this way constrains your data to values that you feel are the most realistic or representative, as the book says. And then you can have best and worst case scenarios. So the limit values chosen for the stated ranges are subjectively chosen, okay? Although perhaps by building on some ranges, range limits derived from some of the other methods that you can see above. So for example, you might decide that the best case value for efficiency is 100%, and the worst case value is 0%. Okay? And best and worst case limits are typically most useful when modeling economic parameters. So for example, highest salary you might need to pay a worker, or the lowest interest rate you might be able to get a bank for a bank loan. So this is also useful in scenario analysis, no? Okay, and then you have, of course, statistical information. You can have your variance, standard deviation, standard error, and your confidence interval. So variance, standard deviation, standard error, these are measures of dispersion. Okay, and then confidence interval, how likely it is that your interval contains the true mean of the population. Okay, so variance is defined as the average of the squared differences from the mean. Okay, standard deviation is the square root of the variance, and then your standard error, okay, is the standard deviation divided by the square root of the number of samples of the data. Now, there is a related statistical metric, and this is the relevant standard error. So, and this is defined as the standard error divided by the mean and multiplied by 100. Okay, which then gives you percentage like a range of values. Okay, so another way to think about the RSE is a metric representing the standard error relative to the mean estimate on a scale from 0 to 100. So as the RSE increases, we would tend to believe that our mean estimate is less precise when referring to the true value in the population being studied. Okay. Now, how about confidence interval? Okay, so ito yung definition ng confidence. For example, you have a 95% confidence interval. Yan yung 1 minus alpha mo. Alpha is the significance level. So say, for example, the significance level of your experiment is 5%. You can have a 95% confidence interval. And that is actually defined as the probability that your parameters, so for example, your mean, lies, okay, between your lower value to your upper value. Okay? So yun yung definition ng confidence interval. So for example, yung mean, okay, in a 95% confidence interval, there's a 95% probability that your true mean will lie within that interval. Okay? Oh, ito, you can see this from the book, no? Example 2-1 is just a simple example on how you can develop a 95% confidence interval given your mean, given your RSE, and your confidence error. Okay? So, hindi ko na di-discuss, so it's a simple example. You can just go through that in your book, no? Okay, and again, this one, you've seen this maybe in high school or even in grade school, siguro high school. Significant figures. Although napaka-basic nitong idea na to, kahit hanggang PhD, nakakalimutan ito. Okay, so I'd like to remind you, and even in the book, this is actually a section in itself. Okay, kasi nakakalimutan talaga siya. So please review the basic rules, no, on significant figures, and hopefully in the projects or even in the homework that you will be submitting when you present your results, they will observe, okay, the guidelines for presenting significant figures. All right. So in general lang, no, often used rules will suggest that the uncertainty of values such as energy and carbon emissions are at least 20%, with even higher percentages for other metrics. Okay, and the authors, at least of the LCA book, generally recommend reporting no more than 3 digits. Okay, and ideally only 2, given the potential for a 20% consideration of uncertainty. Of course, case-to-case basis pa rin, no? Okay, pero wag yung hanggang 20, no, na after the decimal point, or 10, kahit 10. Ang hirap bukod sa ang hirap basahin, it's actually meaningless yung mga numbers. Pampagulo pa sila ng formatting. Okay? Question so far? Okay. Units and unit conversion. So again, I have to remind you, okay, to document your unit conversions, and please make sure that you are using consistent units. All right. So for the benefit of the energy engineering students here, and IEs as well, okay, you might be interested into looking at systems in the energy space. Okay, so you have to take note of energy unit conversions. Okay, and please don't commit the mistake between giving a power unit when you are talking about an energy unit. Okay. These are sometimes terms that are used. Well, they are important terms now. So, for example, when you say site energy, these are energy used. This is energy used locally for a specific task. Okay. Primary or source energy. This is the initial energy needed. Okay. When we talk about heating value, this is the energy released from combusting fuel. So this is in kilojoules per kilogram or BTU per pound. And we can have a lower heating value, LHV, or higher heating value. Okay, ang difference nila, HHV includes energy used to vaporize liquid water in the combustion process. Okay, and then of course you have heat rate. And this considers the energy conversion process, no? So engineering manuals usually suggest the conversion factor 1 kilowatt hour is equal to 3,413 BTU, but this assumes perfect conversion. Now, at a coal power plant, for example, you burn coal, okay, and to heat the water, okay, steam spins the turbine, and then the generator converts mechanical energy. However, there are energy losses along the conversion process, right? Therefore, total energy required to produce 1 kilowatt hour turns out to be actually 10,000 BTU. Okay? So the idea of power plant efficiency, this is the ratio between the ideal conversion and the actual energy requirement or ratio between input energy to energy produced. So for example, the coal power plant, you have 3,413 divided by 10,000, which is 34%. That's the power plant efficiency. Okay. For natural gas plants, they can have about 50%. For solar PV cells, mababa actually 10%, around 10%. Pero tumaas na yata itong number na to. Yeah. Sino nga ba yung mga energy engineering dito who are working in the space of solar PV or LNG? Are these numbers still relevant? 50%, 10%? Okay, you can check, no? Okay, and then emissions and resource use factors, no? When we talk about emission factor, okay, this is the amount of emissions related to each unit of activity. So for example, kilogram of CO2 per kilowatt hour, okay? And this may be obtained from the databases or may be approximated using known physical and chemical characteristics. Okay, so for example, CO2 emissions from burning fuel, okay, in kilograms per million metric BTU is equal to carbon content coefficient, so kilogram C over MMBTU times the fraction oxidized times 44/12, and 44/12 is the ratio between the molecular weight of CO2 and C. So for example, of coal with a carbon content of say 25 kilograms carbon per million metric BTU, and assuming perfect oxidation, the emissions factor would be 92 kilograms CO2 over MMBTU. Okay, so that's 25 times 1 times 1 times 44/12. Okay? So kung wala kayong makuhanan na database. Okay, pero I assume madaming makukuhanan nitong CO2 emissions factor na to for most technologies, okay? Again, just remember to cite your sources accordingly. Okay, and then estimates versus calculations. Now, what if you cannot find the data in the form that you need? or the data that you need to perform known calculation methods. O, paano kung ganon? You are allowed to develop your own way of estimating the parameter in question. Okay, so estimate meaning adequately provide the right answer given the time and the resource constraints, your resource constraints. But they are an educated guess. So you have to provide justification for me to believe that your estimation method is actually reasonable. Okay? Sorry, bakit lumiit ito? Okay, so these are some estimation methods that you can use. Okay, you can have a rule of thumb, no? Maybe in the industry there's a rule of thumb, no? So for example, 30% profit is usually acceptable. That's a rule of thumb. Proxies or similarities, okay? Again, since nare-recall ko siya, from yesterday, one of the suggestions for the thesis is to use, since outdated nga yung Philippine data, ang proxy would be data from Taiwan. That was the suggestion, no? But I had to ask, is the proxy is using Taiwan data for the Philippines in terms of waste characterization a reliable proxy? Okay, so you have to, in that case, you have to be able to show the similarity in between the Philippine context and the Taiwan context, so that you are able to argue that data from Taiwan, because of the absence of data from the Philippines, could be a useful, reasonable proxy for your study. Okay. Simple linear models, okay? And then you have factoring or dimensional analysis, okay? You have bounding, and then, so basically estimating kung ano yung bounds ng data na pwede, ng values na pwede yung gamitin. Segmentation or decomposition, so looking at particular factors of your model, and then triangulation, okay? So you're given information on the parameter, but not exactly at the level that you need for your analysis. Then you can triangulate given the available values. Okay, this is a simple estimation example from the book. Okay, estimating U.S. petroleum consumption per day for transportation. So question, given that the total miles driven for all vehicles in the US is about 3 trillion miles per year, how many gallons of petroleum are used per day in the US for transportation? How would you go about this? Oh, sige, tuloy muna natin. If we assume an average fuel economy, ano ibig sabihin ng fuel economy? Oh, ito yung figure na binigay, no? 20 miles per gallon. So, as the unit implies, fuel economy is what? The amount of fuel required to travel 1 mile. Okay? So, ito, 20 miles per gallon. Okay. So, inassume nila yan, no? And this is an educated guess considering, say, for example, individual experience or maybe numbers that have been shown in previous studies that they have encountered, no? We can estimate, sabi nila, we can estimate that 150 billion gallons of fuel are consumed per year. So, saan galing yung 150 billion gallons? It's 3 trillion miles, to, divided by 20 miles per gallon. Okay, so that is about 400 million gallons per day. Okay, so moving from year to per day. Okay, so that's just a simple way. Now, can you do the same for the Philippines? So first, for the Philippines, we have to be able to estimate ano ba yung total For us, kilometers. Total kilometers driven. O yun pa pala no, yung isang point with respect to knowing the context, the geographic context. When you look at studies, is that there are differing units of measurement. Okay. So for example, in the US, they use miles, we use kilometers. So metric versus English system. Okay, so for the Philippines, meron ba tayong data for total kilometers driven per year? Where do you think could we get this? Hindi naka-perfect state palagi ang data na kailangan ninyo. That is the reality. So you will have to be able to create ways to estimate parameters that you will need in your calculations. Okay? So again, I'd like to emphasize, just be transparent about the way that you estimated things. You have to justify that the way you estimated is reasonable, and always cite your sources. And we prefer primary sources, but if they are not available, secondary sources will do. Okay? Sige, so something that you can do later on. Try nyo. Estimate for the Philippines. This one is just a little interesting, no? Envisioning a 1 part per billion concentration. How many golf balls would it take to encircle the Earth? How many kaya? Assume that the diameter of a golf ball is approximately 1.5 inches and that the circumference of the Earth is about 25,000 miles, okay, roughly 10 times the distance to travel coast to coast in the United States. This is obviously a US example. We can convert 25,000 miles to 1.6 times, tama ba yan? 109? 10 to the 9 inches. Thus, there would be 1.6 times 10 to the 9 inches divided by 1.5 inches, or about 1 billion golf balls encircling the Earth. So 1 billion. Now, if trying to explain the magnitude of a 1 part per billion concentration, think about there being one red golf ball along the equator that has 1 billion white balls lined up. Bakit natin tinitingnan ito? Because sometimes it's so abstract, no, when we present information, when we present results from our studies. Tayo, okay? Tayo pa lang, hindi natin masyadong na-visualize what the numbers actually mean. So this is just a way to help us, make more sense of the data, of the values that we come up with in our studies. And that is a very useful step that we always have to take, no? Because when in the process of doing that, when we try to envision these things, it actually helps us come up with more insights about the results from our studies. It's not just a matter of reporting the numbers themselves, but actually interpreting what those numbers mean. Okay, attributes of good assumptions. So sabi natin kanina, if you really have to, then you can come up with your own estimation method. Okay, and of course, those estimation methods come with their own assumptions. Okay, and any model has its assumptions. So what are the attributes of good assumptions? So one, clarity and simplicity. Okay, so dapat clear and dapat sana, if possible, simple siya. Okay, merong sometimes desire to come off as very sophisticated when you're presenting your study, and because of that desire, you try to come up with very complex problems to make it look more sophisticated, and para mas mukhang magaling yung study. But actually, the simpler, the better. Okay? Sige. Next, correct, credible, and feasible. Okay, so again, debatable yung term na correct kasi sabi nga natin, wala namang model na correct or but in this case, we're talking about assumption. So sana yung assumption naman natin is correct. Okay? Credible yung assumption and feasible yung assumption given the context of your study. And then, of course, iwasan na yung assumption is just there because you have no other option, no? It's just a shortcut, no? Please don't cut corners by including assumptions. No? It should not be a shortcut. If you can actually model something into your or include something into your model, okay, then please do. Huwag kayong gagawa ng assumption just to make it simpler. Okay, sabi natin simpler, better, pero wag shortcut. Unbiased. Okay, unbiased dapat yung assumption niyo. So when you write about your work, justify your assumptions. Okay, justify your assumptions and provide a write-up that reflects your thought process. Okay, why those assumptions can be reasonable. All right. Okay, sorry for that. Validating your estimates. Okay, so this is an example from the book. So basically, you want to make sure that your estimates make sense. Okay, make sure that your estimates make sense. So in example 2-2, o yung example natin kanina about gasoline consumption, which is from the book. It was quickly estimated that the transportation sector in the US consumes about 400 million gallons per day of petroleum. So now, does that make sense? Okay, the US Energy Information Administration. So the US EIA is a very reputable agency when it comes to studies and data on the energy sector in the US and sometimes even outside of the US. Okay, so it reports that about 7 billion barrels of crude oil and other petroleum products were consumed in 2011. Okay, so in a lot of cases, the EIA uses information that are contributed by organizations within the energy sector. So what kind of source is EIA? Siguro in instances where it only received very raw data from actors from the energy industry, and it has to be the first to analyze completely that those raw data, it could be considered as a primary source. However, in most instances, it's actually a very reliable secondary source. Okay? Kasi it collects information from organizations that have already processed them and then presents it in a more organized way to the public. Okay, so case-to-case basis pa rin. So titingnan nyo pa rin, fully documented naman usually yung data na pre-present ng mga organizations na ganito, no, yung mga reputable organizations. They fully document how they collected or analyzed the data. So in that way, you are able to gauge whether it's they are a primary or a secondary source for that particular data. Okay, and you can also gauge the level of trust that you can put on that data. Okay, sige. So moving on. Moving back to our example, the U.S. Energy Information Administration reports that about 7 billion barrels of crude oil and other petroleum products were consumed in 2011. Okay, so medyo outdated, but let's just look at this example. About 1 billion barrels equivalent was for natural gas liquids not generally used in transportation. So that means about 17 million barrels per day. Okay, so about 850 million gallons per day at about 50 gallons per barrel was consumed. That is roughly twice as high as our estimate, okay, yung 400 million gallons per day. But still in the same order of magnitude. Anong ibig sabihin ng same order of magnitude? So although twice as much yung reported value, still within the same order of magnitude. So pag naging 8,500 yan, okay, one order of magnitude higher na siya, di ba? Okay. Sige. So bakit kaya? So now, if you encounter situations like this, nagkaroon kayo ng estimate, tapos meron kayo nakitang secondary source, no? Tapos ito yung ni-report niya. Okay. And this is still under the umbrella of validating your estimates, right? You have to think, no, and you have to explain why there could be such a discrepancy. Okay? And in this example, okay, one could be that we attempted an estimate in one paragraph with two assumptions. So the share of passenger vehicles in total miles driven is not 100%, and heavy trucks represent 10% of the miles traveled and about 1/4 of fuel consumed. So yung assumption na 20 miles per gallon, in-apply natin sa lahat, that is actually a little bit questionable because there are significant differences in terms of fuel economy. And then, again, the miles driven. Okay? So, considering these deviations, our original estimate, while simplistic, was useful. Itong last na sentence, okay, is an interpretation, okay, of how valid your estimate is. Of course, as you can surmise, this is a subjective statement. Okay? So, subject for debate, right? Kung tama ba na useful, o ano sa tingin ninyo? For the author, siguro, they said na they deemed it to be useful because it was still within the same order of magnitude and it was just a quick calculation. Okay? Siguro yung use, and another thing is the use of the information was not very sensitive. So again, depending on your context. Okay? Before I go to that, in the future, in your studies, okay, so sabi natin, di ba, validate your estimates, I would like you to make conclusions as to how valid your estimates are. Okay? Given yung reasoning ninyo. Okay. Break-even analysis, so another form of analysis, no? So this is basically solving for an input value that has a prescribed effect on your output. Okay, ano ba ang pwedeng maging example natin dito? Madaling pag-isipan ng example kapag in terms of money. You've probably already encountered this this idea of break-even analysis, di ba? In terms of money. But in terms of, say, the energy sector. So for example, a quick example is in producing or converting certain amount of energy, okay, to be useful to end consumers over the life cycle, you actually consume also. You actually consume energy, okay, at each stage of the life cycle of that particular energy system. Okay, so some of you are my students in energy engineering. There's a concept of energy return on investment. Okay, so the idea is over the life cycle, you need energy to convert energy that will be delivered to your consumers. So in break-even analysis, to apply the idea of break-even analysis, how much should you be able to deliver eventually to the consumers so that you can sort of return the amount that you spent throughout the life cycle of the energy system. Okay, so that's an example of break-even analysis. Okay? But this is very familiar to you. Next, sensitivity analysis. Okay. The question here, the main question here is, how will your output change when values of certain model parameters change? Okay, so in this simple example, sensitivity of tugboat speed, transit time, as you can see, ano ma-observe natin sa curve? The speed is inversely proportional, no? So the higher your transit time, the lower your speed, okay? So here, this is an example of one-way sensitivity analysis. So you can vary your transit time and see how it changes your speed, okay? Kailan to nagiging useful? Okay, useful si sensitivity analysis kasi pwedeng you're deciding, so let's say this is a general variable y. You are trying to make conclusions based on the value of y, all right? But then y is influenced by a variable x, okay? And you might be interested to know, okay, what value of x will cause you to make a different conclusion because it affects the value of y, right? Kasi magde-depend yung conclusions mo, yung discussion ng study mo on the value of y. Pero y could change depending on the value of x. So what values of x will cause you to have a different conclusion? Okay, so this slide contains the three things that I mentioned earlier. So sabi ko sa inyo, I will look for three things when you write about your study. Okay, when performing your LCA study, remember to fulfill three items below. First, a description of the method used to complete the task. Okay. Second, the result or output. Okay, either quantitative or qualitative of the task. And third, a critical assessment, validation, or thought related to the result. Okay? So, mapa-project man yan or homework, please take note of these three things. So, for example, a very simple example, inputs of plastic were converted from kilogram to pounds. Description of the method, yielding 100 kilograms of inputs. Result. This value represents 20% of the mass flows into the system. Thought related to the result. Okay? Questions? O sige. So let's have an exercise. Okay, so for the first objective, apply appropriate skills for qualitative and quantitative analysis. So the task for that is find the fraction of Philippine energy production from renewable energy sources for masyadong out. Sige, 2015 or gawin na lang natin 2019 yan kasi alam ko updated na yan. 2019, sorry for that. And then objective number 2, document values and data sources in support of research methods. So the task is find and classify sources, whether they be primary or secondary, for the amount of energy used in residences in the Philippines. Validate your findings. Okay, so that's for objective 2. Objective 3, improve your ability to perform back of the envelope estimation methods. So for fun, estimate the number of hairs on your head. And second, estimate the total weight of the population in Quezon City. And then objective number 4, approach any quantitative question by means of describing the method, providing the answer, and describing what is relevant or interesting about the answer. Okay, so the task is, how many refrigerators are bought by people in the Philippines each day? If stacked end to end, how long would it take to walk around them?